We've been talking about the role that image, imagination and memory plays in science, how important it is for us to translate things into a visual information. And here you will have already met in 1.10 when we did Science, Tamlin, who has been studying whales in Kaikoura. And also Tamlin has quite a bit of experience in using photo imaging as part of her data collection and storing of information and processing some understanding about her marine science topics. So Tamlin.
For our research in Kaikoura looking at sperm whales, we use photographs as the main way to record individuals in the population and who they are. So this is a non-invasive way to track individuals, to understand who is in the study area and who isn't, and it means that we don't have to use physical tags that are more invasive. So when we take photos of the individuals, we're on the boat and we wait for a sperm whale to dive, because each sperm whale has individual unique markings along the trailing edge of their fluke. So this is, in this photo you can see the top edge of the fluke has all these different jagged edges, sometimes there's holes in the fluke, and it's like our fingerprint, it's unique to the individual. And so we want to capture an image of the fluke and these markings as clearly as possible so that we can be very certain that the individual we see and match to another photo in our catalogue is that individual. And if we know what whales have been in the area over that time, we can do different things with the data. It means that students like me can come in 27 years later from the beginning of the project and add to that project, collect more data, but also use that whole range of data to look at long-term trends in the population.
And ask new questions.
And ask new questions, exactly.
Yeah. So Tamlin, now you're going to take us through the process of making an image collecting, a data collecting, memory capturing tool, a basic pinhole camera, and we're going to be challenged to use that to capture an image or some information, visual information about the ocean at some particular time and place. Would you like to take us through this process?
Absolutely. So this is the equipment that you will need to build your own pinhole camera. So the first thing you want to get is a box of some type. It's important that you get a box that's made of cardboard that's as sturdy and thick as possible, because we want to have a box that isn't going to let any light into it. Inside, you can see our box is black inside as well as the outside, and what you're going to want to have if your box isn't black on the inside and outside, you're going to want to also have some black paper. So if we look at this box here, you can see it's brown inside, and we'll use this paper to make it dark inside. That helps with reducing the reflection of light inside your box. We'll also have some Sharpie, so that's for also helping to black out the inside of your box. Some insulation tape.
Black, does it need to be black?
Yes. Sandpaper if you've got some.
Yeah, I think that's quite a fine sandpaper, isn't it?
Yeah, it is very fine sandpaper.
P400, P200.
We've got double-sided tape, a board for cutting on, a craft knife if you've got one, but we can also use scissors. And then we've also got our can, which will be useful for making the pinhole of our camera.
Any aluminium can?
Any aluminium can will work.
Yeah, cool.
We have a tape here, so a ruler or a tape measure is
and
useful.
A pin?
Here we've got a pin. This is the perfect tool for making your hole in your pinhole camera, and we'll go into more detail when we're making the camera on how to use this.
Okay.
For making our pinhole camera, we first want to think about making the pinhole and what size we want that pinhole to be. The pinhole is really important because that is what's letting the light into our camera that then exposes our photographic paper. The size of the pinhole also determines how big our camera is going to be. So we need to know the size first before we choose our box and prepare it for taking our photos.
Mm-hmm.
We've got our pin from before, which we are going to use to make our pinhole. And ideally we want our pinhole to be between 0.4 millimeters and 0.5 millimeters. So it's a good idea to practice making pinholes maybe on a piece of card first and measuring those pinholes. We're going to practice making some pinholes now with our pin. We've got some cardboard underneath our practice card, just that we're not damaging any surfaces. And I'm going to start off just making a small hole. So that's hardly pushing the pin in at all. I'm going to practice pushing the pin in all the way. And we know from measuring this before that that's roughly 1 millimeter. And if I then push the pin in about halfway down where the pin tapers, I get a hole which is in between the two.
You'll notice that Tamlin twirls the pin to make a nice smooth round hole. Just checking those practice ones, you see how neat and round they are. Now you're ready to cut your real pinhole out. Piece of aluminium about 3 centimeters by 3 centimeters. Same method, twirl that pin a lot when you make the hole, and then sand the back. Make sure you sand the back quite well so you've got a neat round hole. See that neat sanding? Any burrs will, just make a poorer image. And then check the size. Yep, we're between 0.4 and 0.5 of a mil.
Now that we've created the pinhole for our pinhole camera, we want to use the calculations on the worksheets provided to figure out the focal distance. And this is the distance from the pinhole at the front of the camera to the photographic paper at the back of the camera. Our pinhole diameter is 0.5 millimeters, and so the calculation shows that we need to have a focal distance of between 17 and 18 centimeters. It's 18 centimeters from this part of the box to this part of the box, so this will be really good for using for our 0.5 millimeter pinhole.
It's bound that you're going to have a box that isn't exactly right, and it needs measurements don't have to be precise. There's a lot of approximation and leeway with it, but just like Tamlin here, you're going to have to measure up and recut and fold and shape and then tape up the box to get the right dimensions. It's really a good idea to have a lid that fits right over tightly and firmly, or a lid that folds over, or a box where one half fits into the other half, and that actually reduces the amount of light coming in as well. So once you've done that, once you've scored, cut, folded, shaped, making sure that the distance from the front of the camera, where the pinhole is going to go, to the back, where the photographic film will go, paper will go, is pretty consistently the same, because we don't want the film paper to be at an angle to the light coming in. We want it to be flat on to that pinhole to get a sharper and cleaner image.
So we've got the general size and shape of our black box that we've constructed here, and now I'm just looking at the box and taping up any areas with the black insulation tape that I think might let any light in. So I'm going to tape up any parts of the box where there's a little gap. So here you can see there's a little gap in here, and we've got a bit of an older box, so some of these corners are a little bit worn, so I'm going to tape these up as well, just to make sure that we're keeping out the light as much as possible. Here we have our 18 centimeter box which we've been working on, and we have the advantage with this one that it's already blacked out on the inside. But you may be using a box that isn't blacked out already. So what we're going to do with any boxes that aren't already made out of black cardboard is we're going to black them out, and remember that so that we reduce any reflection of light inside when we're taking our photo. One way you could do that is with black paint, so you could just paint the inside of your box, or you can also use black card and cut out the right shapes and stick that in with glue. So that's what we're going to do today with. So now we have our box, which is all blacked out in the inside with our black paper. You can see I've done the lid as well. I don't need to do the sides of the lid because our box is going to be closing like that. And then I've also used a Sharpie to colour in any of the edges where the paper didn't quite meet. And that's pretty well blacked out now. So we know that this box is roughly 12 centimetres. This is the one here. So we know that we're, from our calculations, that we're going to want to be making a pinhole of 0.4 millimetres. So this is one we've created here. And so we're going to have the pinhole at this side of the box. And what we want to do is cut a square in our box that is a bit smaller than our 2.5 centimetre square with our pinhole in it. And you can see we've made markings with a ruler from corner to corner so that we could get the centre before we made that square, and that centre is where our pinhole is going to sit. So our pan is black on that side, so we're going to put that facing in. Yep. And then tape that. And then we'll create our little lens cap. And we'll just, a little bit tricky, fold the end like that, and it is ready.
The next step Tamlin is taking is she's measuring and marking out a white piece of paper as a template of where the photographic paper will go. The photographic paper is going to be 10 centimetres by 13 centimetres, so she'll mark and cut a piece out that size, and then she can place it in the camera and see where it will fit in the camera before we stick in some double-sided tape that the real photographic paper will stick to. But we can't put the photographic paper in, of course, in the light. We'll have to make our dark room and do all that in the dark, preferably under a red light, but certainly without any other light.
We'll have the photo paper in the lid, and when we're in the dark we'll be doing this, pop that on, and then we're ready to take our image with that one as well.